Hey everybody, and welcome. We are going to do our math review, and so let's go ahead and get started. So practice your timetables. Hopefully those are pretty easy for you guys. 6 times 7 is 42, 8 times 6 is 48, look at a double one. 9 times 8 is going to be 72, so pretty simple hopefully on those. Then these are simplifying expressions. Just remember, when we it's negative 6 plus 10. They're different signs, so you take the difference, which is subtract, which is 4. Since 10's positive and bigger, it's going to be a positive 4. And then this is a negative 12 and a negative 18. So if they're both negative, I always say same sign sum. So you're going to actually add the two numbers together. So 12 and 18 is going to give us 30, and they're both negative, so it's negative 30. I think like someone took $12 from me, then they took $18 from me, so I've lost $30. Okay, this one here, we can just kind of follow through the order left to right. So 9 minus 15, so I have $9, or 9 of something, I'm subtracting 15. So I do have a different sign, so we take the difference here, so 9 minus 15 is going to leave me with 6. 15 is negative, so it's a negative 6. So this is going to become a negative 6. The negative 6 plus 10, which we actually saw right over here, that's going to become a positive 4, and 4 minus 19. Again, different signs, so you take the difference. 4 minus 19 is going to leave me with 15, but since 19 is negative, it's going to be a negative 15. Circle those answers there. And then here we have x's, so if they have the same variable, we can add or subtract the coefficients. Different signs, we're going to take the difference. 12 and 18, the difference is 6. Since 18 is larger and it's positive, it's going to be a positive 6, but the x is still there. The x doesn't go away. Think of it like, you had 18 x boxes, and someone took 12 x boxes. You still have 6 x boxes. All right, simplifying radicals. So we kind of talked a little bit about this in class, but we're looking for two equal factors, and the first couple are perfect squares. So 4 times 4 is 16, so the square root of 16 is 4. 7 times 7 is 49, so the square root of 49 is 7. 144 is a perfect square as well. That is 12 times 12, so the square root of 144 is that one equal factor, 12. Once we get to number 12 on here, we no longer have perfect squares, so I'm going to show you how we do this. So we basically write out our factor tree where two numbers multiply to 27, and that would be 3 and 9. 3 can't go anywhere, but 9 can, and that can go down to 3 and 3, so we use the 9. So I'm looking for two equal factors, and I have two equal factors of 3, so I get to pull the 3 out. But if I have nothing left over, I can't take it out. It gets stuck in the radical. So that's 3 rad 3. Okay. Over here, square root 50. So what two numbers multiply 50? And so the easiest one, I think, would be 5 and 10. So we get 5 times 10. Now 5 is a prime number. It doesn't break down, but we can break this down into 5 and 2. I see two equal factors of 5, so I can take the 5 out, but the 2 is left over. Again, we already used the 10, so we don't use the 10 again. And so we leave the rad 2 behind. All right, square root 48 is going to be, well, we could use 8 and 6 that we saw up here. So 8 times 6. 8 breaks down to 2 times 4, and this breaks down to 2 times 3, so we took care of those. 2, 3 are prime, but then this also breaks down to 2 and 2, so we actually have 2's, and another set of 2's, and a 3. So I actually can take out a 2, another 2, and I leave behind a 3. So if you take out more than one number, you're going to multiply those two numbers to each other on the outside. So I got a 2 out, I got another 2 out, and now I have to multiply those two together, so I get 4, and then rad 3. Okay. And square root of 18 is 2 times 9, which that breaks down to 3 and 3, so we're going to get 3 on the outside, 2 on the inside. And square root of 8 is 2 times 4, and this is 2 times 2, so we got 2 rad 2. That 1 2 comes out, that one other 2 is left behind. Okay. Alright, so here we get into exponents. When you see something squared, it just means to multiply itself twice. So here we go, 6 times 6, that's going to be 36. This is going to be 11 times 11, which is 121. Now this is interesting, it's rad 5 squared, right? So that's actually rad 5 times rad 5. And if you were to do that, now radicals can multiply each other, and when you do that, by the way, this is not for this problem right here. When you do rad 5 times rad 5, you would technically get rad 25. And the square root of 25, well, 25 is a perfect square. It's 5 times 5, we just saw that. So the cool thing is, whenever you square a radical, it actually just kind of makes the radical go away. So the answer is always just going to be that number. So if I took, for example, the square root of 22, and then I squared it, the answer would be 22, because a square and a square root will cancel each other out. Okay? Next we have a rad 8, a cube root of 8. So before, when we didn't see any number up there, it's called a square root. We assume that there's actually a little 2. We're looking for 2 equal factors. Here we're looking for 3 equal factors. So I can't take anything out unless I see 3 equal factors. So we actually broke this one down earlier. And I actually do have 3 equal factors. I have 2, 2, 2. So once I get 3 equal factors, I get to pull that out. There's nothing left behind, so the cube root of 8 is actually 2. We see down here a cube root of 125. So again, I'm looking for 3 of the same factors. So you might know that this is what? 3 times 25. No, not 3 times 25. I apologize. I think that's 5 times 25. That's much better. And then 25 is 5 times 5. And again, we broke that 25 down, so don't use it anymore. We have 1, 2, 3 5s. I'm looking for a cube root, so I want 3 to come out. I need 3 to get 1 out, and there it is. 4 to the third power is just going to be 4 times 4 times 4. So 4 times 4 is 16, and 16 times 4 is 64, I believe. Doing that in my head. Okay. Then we talked in class about exponent rules. So the exponent rule here is when it's a power to a power, you multiply it. So that's just going to be x to the 6th power. And then when you're multiplying, the exponents add. So it's going to be x, 3 plus 4 is 7. Cool. All right, simplify the following expression. So to do these ones, you need to find the like denominators or common terms. Like terms. And so I have a highlighter here, and those are my like terms because they're both x squared. And then these are the same term here because they're x's, and we just combine them. So 6x squared plus 20x squared is 26x squared. And we always like to put the highest coefficient of a variable first, so x squared is the highest, exponent first, not coefficient, exponent. And then 8x minus 4x is going to be positive. 8 minus 4 is a 4x, and then we get just plus 7. And then we do the same thing over here. Look for like terms. We got those, and I circled the sign with it because that's going to be helpful in me combining them. And we got that guy right there, and I don't think anything else. So 14x cubed, negative 7x cubed, so 14 minus 7 is 7x cubed. And then negative 12x squared and 10x squared, so they're different signs. We're going to take the difference, which is 2. The 12 is negative and it's bigger, so it's going to be a negative 2x squared. And then we are left over with 5x and negative 12. All right, now we get into our equations. So this is where we're going to use inverse operations to solve. So I want to isolate or get x alone. So I got to get the x all by itself. So here I'm trying to get x by themselves. So to get rid of the 7, I'm going to subtract 7 on both sides, because whatever I do on one side, I have to do on the other. And so that's going to be x equals negative 22 minus 7. They're both negative. So what's going to happen is we're going to sum them together, and they'll stay negative. It gives me negative 29. Over here, we're going to do plus 12. That's going to give me x equals negative 18 plus 12, which will be a negative 6. Okay. Now we get to multi-step equations, so I have to do more than one thing. And so this is where we do PEMDAS backwards, if you will. So if you notice, here's my x, and it's getting subtracted by 2 and multiplied by 3. So I'm going to get rid of anything adding and subtracting first, and then get rid of anything multiplying and dividing. So I'm going to add 2 first. That's going to give me 3x equals, this is going to become a negative 27. And then I'm going to divide by 3 using, again, inverse operations. It was subtracting, so that's why I added it to get rid of it. It's multiplying, so I'm going to divide to get rid of it. So 3 divided by 3 becomes 1x. Negative 27 divided by 3 should be negative 9. Again, over here, we're going to subtract it by 4 on both sides. So that's x divided by 10 equals 1. And then we're going to multiply, that's the inverse operation, on both sides. So x equals 10. Now this one's a little funky because I did tell you to add and subtract first, but when 2 is dividing everything, it's easiest just to get rid of that first. So it's actually best to multiply both sides by 2. Again, whenever we're solving equations, whenever you do one side, do it to the other. So if I multiply by 2, which is the inverse of dividing, I cancel that out, so I get x minus 10, and this is negative 7 times 2, which is negative 14. So sometimes we'll have to take care of that first. And then we're going to add 10 to both sides. And we get x equals negative 4. Okay. Some of you will still have problems with these adding and subtracting integers. You know, be very careful. I would say, I do have a calculator right by my side if I need to double check myself, especially on a test. You don't want to make those simple mistakes. So double check yourself. Try it and then double check with the calculator. All right. But we should be able to do these without a calculator for the most part. So again, here we're going to subtract the 4 first. That's going to be 100 minus 4, which is going to give me 96. That's negative 12x equals 96, and then divide by negative 12. And here's a good example. Like, you might not know how many times 12 goes into 96. You could take a guess. Like it's probably close to 8, because, you know, 12. It's not going to be 9. That would probably be too big. It's probably going to be 8 or 7, something like that. But feel free. You know, if it's a bigger number and you need to, take out a calculator and help yourself out. And so it is negative 8, which we kind of were thinking it was probably 8. Maybe we wasn't sure if it was going to go in evenly. So that's a negative 8. All right. So 33, we have to combine like terms before we isolate the variables. So we have to get x together before we isolate this. And so we get 5x and 3x, which makes 8x minus 8 equals x minus 1. And so here we have x's on both sides of the equation. We want to get them all to the same side. And so I would say move the smallest, pretending you're moving for your friend, like he's moving, you know, to a different house or apartment or something. And you're there to help, but you're going to like, I'll move the least amount because this isn't my stuff. I don't want to break anything. So let's move the x. It's a positive x, so we're going to subtract it over. And whatever I do to one side, do the other. So I get negative 1 equals, this is going to become 7x minus 8. Then we treat it as a two-step problem where we're going to add the x over. And we get 7 equals 7x. And then we can divide by 7 nicely and get x equals 1. All right, 34. We want to combine like terms here. So that's going to be a negative and a negative, but they're not like terms. So 18 and x don't share. But we do see an x over here, but we still have to distribute. So this is distributive property. I see the 6 outside of these parentheses. Oops, sorry, my screen went there for a second, and then my classroom went dark. Just like that. Hold on one second. There we go. Let there be light. Okay, so 6 is on the outside, and it's distributing into these parentheses. So we want to go 6 times 1, which is 6, and then 6 times 3x, which is going to give us 18x. And then we have negative 18, negative 6x equals 6 plus 18x. All right, let's move again the smaller one. Well, negative 6 is smaller than 18, especially since it's negative. And so we're going to add that over. And we're going to get negative 18 equals 6 plus 18 plus 6 is going to give me 24. X, and then I'm going to subtract the 6 over, which I don't have a lot of room to show, so I'm going to rewrite it up here. So that cancels. This is negative 6 and negative 18, which makes a negative 24. And then we divide by 24. X equals negative 1. Alright, now we're just getting a little bit longer. I'm going to go a little bit faster on these ones, but we're going to distribute first. So that's negative 5. Negative 5 times negative 5 is 25x. 5 times these is going to be negative 40x, and a negative 10 equals, and I'll combine those to make negative 12x. Okay. So I'm going to combine like terms on this side. So I have negative 10 and negative 5, that's negative 15. I have a positive 25 and a negative 40, which is actually going to be a negative also 15x equals a negative 12x. Negative 15 is actually smaller than negative 12, so we're going to add 15x over. And we get negative 15 equals 3x, and then we'll divide by 3. X equals negative 5. Okay, so pretty long question. We typically don't have really long algebra problems like that in geometry. Usually they're more apt to be like, 32 or something like that. All right, here we have a negative out in front, so we have to distribute the negative through, so everything in there becomes negative. Here we have a negative 6, so everything's going to be multiplied by 6 and change signs, so it's going to become positive 42 and a positive 6x equals 36. I'm going to combine my like terms. We'll do this one first. That's negative 1 and 42, which is going to be 41. Negative 7 and positive 6 is going to be a negative 1x. And then we get 36. So we'll subtract negative 41. And negative 1x is going to equal 36 minus 41, which I believe is 5 off. So we'll go with negative 5 since 41 is bigger. And then we divide by negative 1, which is just going to change that 5 to a positive. Okay, let's flip it, rip it, and grip it. Alright, Mia won $77 in a raffle at her team's fundraiser. Later she split it amongst her friends and gave 14 to each, keeping 21 for herself. How many friends did she share it with? Okay, so whenever we see this word each, it means it's probably going to be a variable. And if she's keeping 21, that is going to be a constant. So we have to think of how can we write an equation to solve this. Well, we know that she has $77, but she's going to give out or save for herself all the money. So 77 has to equal how much she gives out. Okay? And she's going to give 14 to each of her friends. Okay? So 14 to each. We don't know how many friends, so we'll call her friends X. I don't know how many friends she's going to have. Okay? So if we just did that there, this would basically be saying how many, I would just be dividing 77 by 14. But she keeps 21, so she's going to give/keep $21. Okay, so she's going to give 14 out to certain people and keep 21, so we have to account for that. So, because when we solve this, we're going to subtract the 21 right off the bat, which makes sense, right? She's not going to, she said, I got $77, I'm going to keep 21 to myself. She's going to take that 21 out of the 77 right off the bat, and that will bring her down to $56. And then she's going to say, okay, I'm going to give $14 to each of my friends. How many times does 14 fit into 56? And that should tell us how many friends she gives it to. And she ends up with 4x, or she has 4 friends. 38, for a field trip, 11 students rode in a car and the rest rode on a bus, and 8 buses with the same number of students on each. Again, here's that each term, right? So that's probably a variable. How many students were on each bus if 315 students went on the trip? So we know that there is students, and we have either they went on cars or a bus. Okay, well, we have 315. We know 11 students rode in cars, plus we know that there was 8 buses, but we don't know how many were on each bus, right? So if there was 5 on each bus, then it would be 8 times 5. But we don't know, so we're going to do 8x. That will represent how many students we have for the bus. Okay? So we'll subtract the 11 right off the bat, and we get 301 equals 8x. And then we say, all right, let's divide 301 people into 8 buses, and then we can see how many were on each bus. And we get by the way, I think that says if 315 students went. Okay, so it doesn't break down evenly, so we get a decimal here. I got 37.625. So that's why I'm taking a little pause real quick. And so what does that mean? How many were on each bus? So we're going to say about 38 because we don't want to say half people. So about 38 people. Just because it doesn't go in evenly, so we must have had... oh, that's because this is 304. My bad. That's my problem, not yours. So it is 38 people exactly. I was like, I know I'm doing something wrong here. 315 minus 11 is 304, not 301. Thank you, Mr. Smith. All right. Ashton and James are the same height. If Ashton's height is represented by 6 plus 15x, and James is represented by 6x plus 42, find the value. Well, if I know Ashton has the same height as James, that means they're equal. And so all we have to do is set 6 plus 15x equal to 6x plus 42. We do this a lot in geometry, where we say, hey, this segment is the same as this segment, but they're written weird. That just means we have to set them equal to each other. So again, we want to subtract this 6x over, and we're going to get 6 plus 15 minus 6 is going to give me 9x equals 42, and then I'm going to subtract the 6 over. And so we get 9x equals, and that's going to be 6 minus 42, which is going to be 36, and then divide by 9. And then 36 divided by 9 is going to give me 4. So find the value of x. So all we had to do is find the value of x. We didn't have to find heights. So x equals 4. Okay? Riley and Simon compete in the long jump. Riley's length can be represented by 6x minus 15. Simone's can be 9x plus 18. Simone jumped twice as far as Riley. Find the value. Okay, so this is kind of similar to the one that we just did, but here's the thing. Right? They're not equal right off the bat. Right? So Ashton and James are the same height. They don't jump the same. Simone jumps twice as far. So Simone jumped 10. Riley would only jump 5. So to make it equal, we'd have to double Riley's height to make this equation fair. Okay, and so we're going to take Riley's height and we're going to multiply it by 2 and set it equal to Simone's. Okay, so we have to distribute here, and I don't have enough space, so just get a little extra sheet here. So that's going to be 12x minus 30 and 9x plus 18. And then I'm going to subtract the 9x because it is the smaller one. And that gives me 3x. And I'm going to add the 30 over. So it's going to give me 48. And then we're going to divide by 3, which I think is 16. I was just using my calculator just to double check. And it was. So value of x is 16. Okay? Whew, word problems, am I right? All right, so simplify, simplify, simplify. All good stuff. Let's see, I think I'm going to make this a two-parter, so I'll get to this on part 2. So, all right, guys, thank you for your help. We'll see you on part 2.